Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at how to solve the question on electrochemistry that's on the board. And the question is as follows. Calculate the electrode potential of the copper electrode dipped in a solution of 0.1 mole per dm cube copper sulphate at 25 degrees Celsius. The standard electrode potential of the copper electrode is 0.34 volts at 298 Kelvin. Now, the first thing to do to solve this question is to recognize that at this copper electrode, what happens is that copper 2 ions undergoes reduction by accepting 2 electrons to give copper. So what happens at the copper electrode is reduction. So if we're told to find the electrode potential of the copper electrode, it means that we are simply told to find the reduction potential. The second thing to pay attention to is that we are looking for the electrode potential of a single electrode, which in this case is the copper electrode. And in my video where we derived the formula for the Nernst equation, I also showed you the formula you can use to find the electrode potential of a single electrode, depending on whether that electrode is the anode or the cathode. Now, we have established that at this copper electrode, reduction takes place. And in a galvanic cell, reduction takes place at the cathode. So, the next thing to also note is that the number of electrons in this case is 2. And we've been given the standard reduction potential to be 0.34 volts. And we're told to find the electrode potential of the copper electrode. So, it is important for us to remember the formula to use. Since reduction takes place at this electrode, the electrode potential in this case, which is going to be ECU, is simply going to be EOCU plus 0.0591 over N log base 10 concentration of Cu2 plus. This is the formula to use. Now, we are told that the concentration of copper sulphate is 0.1 mole per dm cube. Now, in copper sulphate, you have copper ions. So, the concentration of Cu2 plus will also be 0.1 mole per dm cube. Now, we can actually find the value of the electrode potential of copper. So the electrode potential of copper is simply going to be 0.34 plus 0.0591 divided by 2 log 0.1 base 10. So this is going to be 0.34 plus 0.0591 divided by 2 multiplied by minus 1, because the value of log 0.1 in base 10 is minus 1. And when this is solved, the electrode potential of copper is going to give us 0.31045 volts. So this is the answer to the question, and I want to believe that this explanation is clear. In my previous lesson on Nernst equation, I told you that to find the reduction potential of an electrode, it is simply going to be the standard reduction potential plus 0.0591 over N log the ion at the electrode. In this particular electrode of copper, reduction is what takes place. So the electrode potential of copper that we asked to find is the same as telling us to find the reduction potential of the copper electrode. And so it is going to be ECU, where ECU represents the electrode potential of copper, is equal to ECU naught, which is the standard reduction potential of copper, plus 0.0591 over N, where N stands for the number of electrons involved, log the concentration of copper ions. And when this is solved, you're going to get 0.31045 volts. Thank you for watching. See you in the next lesson.